Can you see these bubbles in this tube here? And can you see this flask here, which is full of air? Watch carefully what happens when I put my hands around the flask. Watch the bubbles carefully. I'm now warming the flask up. I'm warming the flask up. And as I do so, you can see the bubbles are going up. And the reason why the bubbles are going up is because the air inside is expanding enormously just by a very tiny change of temperature. Now let me show you something completely different. I'm going to show you what happens when a mass of air is cooled. A fixed volume of air is cooled. And here I have a balloon. This balloon is full of air. It's contained inside the balloon. Here, there, the flask contained air. Here we have in a balloon. Watch carefully as I cool this balloon down by pouring liquid nitrogen over it. So we're now cooling down, the opposite of what I did in the first experiment. We're cooling the balloon down to a temperature of minus 196 degrees centigrade, which is the temperature of liquid nitrogen. And then you see the balloon has collapsed. A colossal change of volume once again. So, but this, you see, this collapse can be reversed. These are physical changes. And if I now take the balloon out, which is down to a very low temperature, you'd think there's nothing in there. But if I now warm it up again, shake it up in the air, throw it up a few times, then in a very short space of time, the balloon will be restored to its former shape. And why is this happening? Because the air inside has now become fully warmed up, and so the molecules inside have got the energy to exert a pressure, and so there it is. What I have just shown you is the colossal changes of volume that gases undergo, in this case it was air, when subjected to changes of temperature.